Alright, so today we're going to be talking about how to make an momentum bar graph or an MVP chart. So first up, what is an MVP chart? Well, an MVP chart helps us keep track of the momentum that objects have before and after a collision. It also keeps track of the total momentum before and after a collision for a whole system. Complete and correct MVP chart will help you set up an equation to find the answer to a problem. So here's a MVP chart. You'll have one momentum bar graph for the initial and then one momentum bar graph for the final. Now, these are very similar to LOL diagrams because they're bar graphs. The only difference is instead of there being different types of momentum, there's only positive momentum, so in the positive direction, and negative momentum for objects moving in the negative direction. So each row is for each object. And then we also have one for the total momentum as well. So steps to completing an MVP chart. We can boil this down to 5 steps. First, you have to identify the objects in your system that are involved in the collision. You want to list your givens and unknowns. An MVP chart really is an organization tool as well that helps you put everything in place and organized. Secondly, you want to determine the momentum for each object. We'll use the momentum equation, P equals mv for that, and we're going to create bars to illustrate the magnitude and direction. Third, we're going to calculate the total momentum before and or after the collision if we can. 4, we're going to use the momentum conservation in order to equate the total momentum before and after the collision. 5, we're going to determine the momentum of the object that we want to know more about. Usually, the problem will say something like, what is the mass of the object after the collision? What's the velocity of the object before the collision? This is when we're solving for the unknown. Alright, so before our example, what we're going to do is just talk about the anatomy of an MVP chart. So about what I was talking about before, we have an MVP chart consists of 2 momentum bar graphs. Now, these bar graphs are sideways, okay? Unlike LOL diagrams where our bars were vertical, for an MVP chart, our bars go left and right, and that's because we've got positive momentum and negative momentum. Positive momentum and negative momentum. So each row is dedicated to an object. And each row is dedicated to an object. The last row is always about the total momentum in the system. If there are no impulses acting on the system, so there are no outside forces, these 2 momentums, the total momentums, will be equal to each other. So what we're going to do here is draw bars that will illustrate the momentum of each object. The left side is for the negative, right side is positive, and the line here just represents 0. Alright, so here's a sample problem. We've got a blue 2 kilogram billiard ball is traveling to the right with a 10 meter per second velocity, and then a red 2 kilogram billiard ball is traveling left with the same velocity, and then they collide. And what we have here is we know that the blue billiard ball ends up traveling to the left with 10 meters per second now, and we want to find the velocity of the red billiard ball after the collision using our momentum bar graph. Alright, so step 1. We want to solve for the final momentum of the red billiard ball. So what we're going to do first is identify the objects that are involved in the collision. So we have the blue one, which I'll just call blue, and it's got a mass of 2 kilograms and a velocity of positive 10 meters per second. And in the final case, I know that blue this time still has a mass of 2 kilograms, so I'll put that in. And this time its final velocity is negative 10 meters per second. Now, momentum is a vector, so the directions are going to matter. So these positive and negative signs for the velocity definitely matters for getting the problem correct. Now, let's go back to our second object. We know that it's red. We'll go 2 kilograms. And initially it has a velocity of 10 meters per second. And red here has a 2 kilogram velocity. And we don't know our velocity in the final case, so what we have is just a v here. So any unknowns I'll keep as just v. All right, so step 2 says we need to determine the momentum for each object. And we're going to create bars to illustrate the magnitude and direction for these momentums. Now, first up, we've got a momentum. Doesn't have a special unit, just different from energy where we had joules. Momentum just has units of kg times meters per second. So going for each one, we've got the red initially has 2 kilograms and it travels with a velocity of negative 10 meters per second. Now, to just clean this up, I do encourage you to do your work in units, but I don't have limited space here, so I will just write negative 20 here. Initially, for the blue billiard ball, I have 2 kilograms times 10 meters per second. That velocity is positive, so I'm going to write this in the positive side for positive 20. And for the final in the blue, I have this is negative 20 because its velocity is now negative 10 meters per second. Now, since we've got bar graphs here, we're going to create bar graphs out of this. So you want to try your best to draw this to scale. It's not going to be perfect, but do your best. And we're going to have a red one here. Color that in. And since these are both the same size, the same magnitude, their directions are just different. You want to make sure that you draw them the same length as best as you can. Now, you'll notice a few things. First up, the total momentum initially is going to end up being 0 because positive 20 plus negative 20 gives you 0. So what I usually do is just bolden this in here. I'm going to use purple. So we're just going to color that in. And you'll also notice that this red in the final, we do not know anything about that yet. So I can't really, from our momentum bar, from our information, can't really determine the momentum yet. So step 3 says we want to calculate the total momentum before or after the collision. Now, we're going for any of these bottom columns, and because we don't know everything about the final case here, we'll see that the velocity there is unknown. We can't really do anything about that. Now, we can, however, sum up all of the momentum in the initial case before the collision. So when we do that, if we add up positive 20 to negative 20, we find that we have 0. So what I'll typically do there is, if I have a zero momentum, what I'll just do is bolden the zero there just to show me that the momentum there is zero. Okay, so that's all we have to do here. We can't really move on based on what we have. So step 4 says use momentum conservation to equate the total momentum before the collision to the total momentum after the collision. So in this problem, we have the total momentum before zero. What we're allowed to say then is that the momentum is the same, the total momentum rather, is the same after the collision. So if we have zero total momentum in the system before, we have to have zero total momentum at the end, because momentum is always conserved in collisions. Doesn't matter if it's elastic or an inelastic collision, momentum is always conserved. All right, so for the final step, and this might be a little tricky, we need to do some reasoning. So step 5 says determine the momentum of the object that we need to find more information about. And what we're talking about is red in the final case. Now, here's the thing. We know that the total momentum is zero, and we know that the momentum of one of the objects, the blue billiard ball, is negative 20. So we can do a few things. We know, just based on the fact that we have a nice diagram here for us, we know that in order for the two momentums to add up, we've got to have a positive momentum here. And not only that, we can also figure out the number. And there's only one number that does the trick. So you need to be asking yourself this question. So we want to think about what number, when added to negative 20, gives us 0. So what number, when added to negative 20, gives us 0? And there's only really one number that does that. That's positive 20. So we know that the red billiard ball after the collision has to have a momentum of positive 20 kilograms times meters per second. And from this point, all you need to do is solve. So we have the momentum equation is P equals mv. We know that this is positive 20 kilograms times meters per second. And we know that the mass was 2 kilograms. We want the velocity. So solving for the velocity, kilograms cancel out. We have 20 divided by 2. And that just gives us a positive 10 meters per second. So there's a solution, and there's how you solve a problem using a momentum bar graph or an MVP chart.